So now that we've learned the rules for drawing a free body diagram of a truss, let's go ahead and practice. So let's go ahead and draw our joints without the members. Let's just draw the joints out here. This is C and then B is up here. And let's go ahead and start sketching the forces acting on it. We already know that D has some force pulling down. We'll call it force of D because that's what it's called in the picture here, and that's 500 pounds. And we also know there's a reactionary force at joint C for the roller, and two reactionary forces, one at A that's perpendicular and one at A that's parallel since it's pinned. And we'll call this one at A that's parallel, we'll call that rack since it's reactionary force at joint A in the X direction. And then likewise, we can call this reactionary force at joint A in the Y direction, good old Ray. We can call this one Ricky, or reactionary force C in the Y direction. And what we need to understand about sketching free body diagrams is the sum of all forces, both in the X direction and the Y direction, equals 0. And what we mean is all forces left and right cancel out, and all forces up and down cancel out. And if we look, there's only one force in the X direction, and that's Rax. So we already know Rax has to be 0, because it's the only force, and it has to add up to 0. And the sum of all forces in the Y direction also have to cancel out. Since there's more of them, it's a little bit trickier, but not too much trickier. We can say that Ray and Ricky combine with this force in the D, or the force at D, which we called force of D, which is just a force of gravity at D. But these all combine to be 0 as well. And that means that my downward forces have to cancel out my upward forces. So what this means is Ray and Ricky, and I'm starting to sketch within my free body diagram, so I'm going to go ahead and draw this over here. What this means is that Ray and Ricky combine to cancel out this force of D. And so as we can see, all of our forces outside of our system cancel out. So this statement is true. Both of these statements, I should say. But what you need to realize is that these statements need to hold true at every single joint. So if joint D is being pulled downward with 500 pounds, it means it needs to be pulled upward with 500 pounds. By member BD, it needs to cancel it out. And if BD is being pulled up at D, if the member or if the joint's being pulled up, then that means joint B is being pulled down. In other words, member BD is acting as a rope. So it's under tension or positive. And I always like to go to the roller next, only because there's less happening at the roller. We always have racks acting on A, which can confuse it, although it won't this time. But likewise, we have an upward force at Ricky, so we need a downward force canceling it out. And that downward force will be the compression of BC. And I need to make sure I add this arrow for the vector of BD. But if BC is being pushed down and to the right at C, it needs to be pushed up and to the left at B, which makes this system under compression or negative. Well, now we have an upward and a downward force, but now we also have a rightward force on C, so we need a leftward force to cancel it out. And that leftward force will be applied by the member DC, or you can call it CD. It really doesn't matter. The point is, it's the member between joints C and D. And if it's being pulled to the left here, it has to be pulled to the right here at D, which makes DC under tension as well. Well, now as we can see, joint D is being pulled to the right, so we need an equal and opposite force pulling it to the left, which will be provided by AD. And if AD is pulled to the left here, it needs to be pulled to the right at the other end, which is at joint A. And that means it's under tension as well, which makes member AD a positive vector as well. And now we have a rightward force at A, and we have an upward force of A. And you might say, well, there's two rightwards. Well, we learned earlier that this was 0. But it won't affect it either way. We have an upward force and a rightward force, so we need a down and a leftward force canceling it out, and that will be applied by vector AB from member AB. And if AB is pushing down to the left on this end, then member AB will be pushed up and to the right at this end, which means it's also compression negative. And if we look, all joints have all of the forces canceled out by upward and downward or leftward and rightward forces. Even joint B has a downward force, but it has two upward forces to lift it up. And we aren't learning how to do the math just yet. We're just talking about the concept of the upward forces canceling out the downward forces and the leftward forces canceling out the rightward forces. And we'll start learning in the next lesson how to find the actual numbers that cancel out that are equal and opposite. But what I want you to realize is forces that are pushed apart, either up and down or left and right, these are compression forces. And likewise, forces that are pulled inward, either left and right or up and down, these are tension forces. And again, if this seems backwards to you, remember we are only talking about the joints. We're talking about the joints being pushed outward, which means the member is under compression. And we're talking about the joints being pulled inward, which means the member is under tension.